Okay, so we've got a collisions question for question 5 of this paper, and here the first part is fairly standard stuff really. We've got particle A is of mass 3m. I always think a before and after for each collision is a good idea. So before, this one is being moved along with velocity u. Okay, because it says initially at rest and then it goes on to say that it's been moved with speed u. Then the particle, if we call this one A, this one the particle B, which has got mass 4m, it's obviously got a speed of u, 0, and particle C has also got a speed of 0. Now afterwards, if we call the particle of this one v1, that's A, and we call the velocity of this one v2, and this one hasn't been involved in a collision C, so that's still got 0. Okay, so that's 3m and 4m. So if I use the principle of conservation of linear momentum, reasonably straightforward equation can be gained here. 3mu, that's the momentum before, is equal to 3m v1 plus 4m v2. M cancels, so we're left with 3v1 plus 4v2 equals to 3u. Right, now Newton's law of restitution, which is speed of separation over the speed of approach, is in this ratio E. It's always better to have that in your mind in words. Do not try and convert that formula to symbols, because every situation is different and the signs don't work out, and you have to be reasonably flexible in your approach of how to use that. Just parrot-fashion quoting that as E is equal to V2 minus V1 is it over U2 minus V1 is likely to lead to disaster. So in this case the speed of separation, well, it is V2 minus V1 in this case, so that's E is equal to V2 over V minus 1, but we do know that E is 1/3, over the speed of separation, which is U minus 0, which is U. So that gets me nice and simply to 3V2 is minus 3V1 equals to U. Okay, now looking at this and looking at this, I can see in particular that 3v1 eliminates nicely if I just add the two equations. So that's what I'm going to do. I'm going to add those two. v1 is going to go, and I'm going to end up with 4v2 plus 3v2 equals 4u. So that's 7v2 equals 4u. v2 is equal to 4u over 7. Now, slightly different to many questions, it's talked about the impulse. Now, impulse, so the magnitude of the impulse is equal to the change in momentum. So impulse equals to mv minus mu. I can choose either of the particles here. It would seem more sensible, it only wants a magnitude, to choose the one which had a velocity of 0 before, because effectively what I'm going to be doing is doing final velocity, which is the mass of that one is 4m times 4u over 7, take away 0, so that's 16 mu over 7 as required. Okay, so that's the first part of the question done. Okay, relatively standard stuff here. Now look at the kinetic. Let's look at the second part of the question. After the collision between A and B, there is a direct collision between B and C. Okay, and it's also said after this collision between B and C, the kinetic energy is that amount 7245 of C is 72 over 245 mu squared. Now I'm minded to work out what that velocity is. So velocity of C after collision is going to be to work at, we can use that by saying a kinetic energy, which is 72 over 245 mu squared is equal to, now the mass of C is 5m, so it's half times 5m v squared. Now m cancels, but often, if you get funny little fractions going on in this, the chances are the numbers are going to work out relatively nicely. We end up with v squared is equal to, let's star it because it's the velocity of the other particle at the end. So it's, so v squared is equal to 144. Because that's 2 times 72 over 1225 u squared, and that breaks down nicely if we work out the square root of that to 12 over 35 u. So now we've got a second collision going on now, so we can say A is actually not going to be affected in this collision. B and C. Right, now we've already shown that this has got a velocity of 4u over 7. We didn't need to work out the velocity of A anyway. It's not going to be affected by the second collision, and so we're not really concerned about it. But this one, if we call the velocity of B and C the velocity of B, let's call that V3, and V4, we've already worked out the final velocity of this as 12 over 35 u. So let's just write in there, and A, as I say, is the same as it was before there. I'm not actually bothered by A. Okay, it is worth thinking about just in case there was another collision. You do have to be, aware of what's going on overall. A is not affected by the second collision. So we're going to use momentum, so conservation of linear momentum. That's going to give us the momentum before, which is 4m times 4u over 7, because this is 4m here, is equal to 4m v3 plus 5m times by 12 over 35 u. Okay, well, obviously, as often happens in these situations, m cancels. Now, if I do a bit of rearranging there, I'm going to get 4v3 is equal to 16, because this amount here is 16u over 7. This here, I notice that the 5 here cancels with the 35 here, which also makes it out to 7. So that's minus 12u over 7, which is equal to 4u over 7. Okay, so that gives me that v3 is equal to u over 7. I haven't actually kind of plunged into this, but I haven't actually talked about what they're asking for. They didn't actually ask for that final velocity, it asks for the coefficient of restitution, which unusually we've got a different coefficient of restitution for the particles between B and C as we did for between A and B. But it's no problem now, we've worked out V3, so because we can work out Newton's law of restitution, speed of separation over speed of approach, E, is equal to the speed of separation, so that's the larger of the velocities take away the smaller of the velocities, okay, as they approach, and the 4u over 7, which was our initial velocity at the bottom, take away the 0, which I haven't bothered to write. Right, so if I multiply everything here by 7, if I put the top over a common denominator or multiply both by 7, I'm going to get 12u over 5 minus u over 4u. If I times the top and bottom now by 5, could have times by 35 in one go, but never mind. That's 12u minus 5u over 20u, which gives us 7u over 20u, and obviously the u cancels, so E is equal to 7 over 20. There you go. And that's that. That is that question now complete. Thank you.